Okay, let's proceed with our final example, which is a triple integral. So we have here, again, atong unahon is isulod and then hinahimay mo, gawas. Okay, the first one that is we just integrate this with respect to z. Since there is no z, we treat this as a constant. Then that is just equal to 0 to y, and then we have the z sine y squared evaluated from 1 to 3. Now 3 sine y squared minus sine y squared, that is just equal to 2 sine y squared. Since 2 is a constant, we can factor that out. Then we will have 2 integral of 0 to square root of pi over 2 integral of 0 to y. Then we have the sine y squared dx dy. Now, we are asked to find the integral with respect to x. Since y man atong variable, then therefore we need to consider the function as a constant. So that is just equal to integral of 0 to square root of pi over 2. And then we have the x. Okay, don't forget the 2 again. X sine y squared, and then that is to be evaluated from 0 to y dy. So if that is 0, that becomes 0. And then if 2, I will just uh, substitute dy, then that becomes y sine y squared dy. Now, if you look closely at the equation, if we let our u as the y squared, then our du becomes 2y dy. So that becomes, so we have a 2y here, that becomes integral of sine u du from 0 to pi over 2. And then the integral of sine u is simply negative cosine u evaluated from 0 to pi over 2. We just resubstitute back the value of our u, that is negative cosine y squared evaluated from 0 to pi square root of pi over 2. Okay, don't forget that when you're evaluating trigonometric and functions, you turn your calculator in radians mode. So you have a negative cosine. So we have the square root of pi over 2 squared minus negative cosine 0. Again, cosine 0 is 1. This is 1. And then we have a negative here that becomes a negative. And a negative of a negative, that becomes a positive 1. How about here? We have the square root of pi over 2. We square that, we have pi over 2. And what is the cosine of pi over 2? That is simply 0. Therefore, the answer for this one is just equal to 1. And then this will be the answer for our differential equation for the triple integral here. Okay, so that is just the basic concept of our topics on the iterated integrals. The iterated integrals is just that we have integrals, but the function is not of one variable, but of more than one variable. So here we have the three variables. We have the variable with respect to s, we have the x, we have the y, and we have the z. Now, what happens if we were asked to find the integral is simple. Just look at the integral or the variable of integration. If, for instance, here we have the variable of integration, we look at z, that is z. Therefore, anything in the function z should be integrated following the integral rules. If uh, the variable is not with respect to z, let's say it is an x or an y or a y, therefore, we don't need to integrate those using the integral rules because they are not with respect to the shown variable of integration here. So we treat them as constant. and move our way in solving the given differential equation. Now, if you have a double integral, so you start with the inner and with the outer. With the triple integral, same thing. So good sa pinakasunod, start with the inside, with the middle, and then with the outermost. Now in sketching this one, the for the double and triple integral, you just look at the limits. Now for this one, this we already have three axes. We have the this one here, we already have our x, y, and the z. And then for the z, yung lower and upper limit, that is 1 and 3. So that is here. And then for the x, that is 0 to y. But let's look at the y. We have the 0 and the pi over 2. Let's see, we have our pi over 2 here. And then sa x pod, we have the 0 also and the y. So here, we have a line. So since the x is greater than or equal to 0 but less than or equal to y, therefore we have an x is equal to y. So we have a line, and then that forms here a volume. So yung ano na siya dali. But and then in the previous example, we have an area that is bounded by our inside and the outer or the outside limits. So mula na siya inyo lang tanaw din ang outside and inside limits in order to graph or sketch the given integral. And then you just apply those basic integration rules. Then eventually you will be able to get the volume or the area of the given uh, differential equation. For this one, for our example 11, we get a 1 cubic units.